Well, happy Tuesday evening. Welcome to our get-together. Bruce, you got to take me. Thank you. I take myself. Hi. It's been Tuesday nights together for the past 9 weeks. Very happy to have everyone with us tonight in our Zoom classroom. We have 15 folks with us and about 8 folks watching us on YouTube, and I greatly appreciate it. This is the general class for amateur radio, and we're in chapter 9 tonight of this book, the General Class License Manual, 10th edition. This just came out this summer. It has the current question pool. This is the book that you want. And we're going to cover the last chapter in the book tonight. Then the plan is to take a 5-minute break, an intermission, and then we'll come back and we'll take a 35-question practice test together tonight. You'll grade your own paper. We won't see your results, but just together. And then at the end, maybe if you have any questions or whatnot, we can cover those. So that's our plan for tonight. But first, I'd like to do a little ad. Bruce, if you would take my laptop, please. The Amateur Extra Class. We will be having an extra class in this format starting in January 9th, Tuesday nights, starting at 6:30 p.m. Eastern Time. Each class will run for 2 hours and will be running through April 30th, 2024. We'll be working out of the American Radio Relay League Extra Class License Manual, the 12th edition. And down below there's a quick link that you can go to. That is an affiliate link. We do make a few pennies off of it if you use that. And we appreciate that. And we'd love to have you join us. It's free. Our classes are always free. So if you'd like to be a part of the Amateur Extra Class starting in January, just send me an email, w4eey@arrl.net, and say, Gary, I would like to be part of the Zoom classroom for the Amateur Extra Class. And I'll get you in the class roster and on the mailing list. Now, we will, Bruce, if you come back to me for a second, we will be streaming live on YouTube. And for many, that's the preferable mode to participate in the class. You can participate at your own pace and at your own time frame if you can't make it on Tuesday nights. So if you'd like to be part of that, again, just email me. Go back please to the laptop at that email address and say, Gary, I'd like to be part of the YouTube mailing list. I'll put you on that, and that way you'll get all of the information and announcements. So as I mentioned, tonight we're going to be talking about Chapter 9, Safety, and then we will take a 35-question practice test. Next week, entirely optional, but if you'd like to come back, we will have 2 more practice tests, and we'll wrap up the class at that time. The practice tests give you a chance to, go through, find your strengths and your weaknesses, and I think it'll be good for everyone. I had a question I see one of our students here, Alfred. I see you're here with us. I understand that you passed your general class. Would you like to tell the class about what your experience was like?
It was an awesome experience. The only problem is there was too many people there to take the test, and the line was long, and the waiting period for the results was just horrible. But aside from that, everything went well. The test was okay. I did well. I only missed 4 of the 35. And they had plenty of calculators there, and they asked if you wanted to borrow a calculator to take with the test. So that's one thing that they had plenty of on the table and stuff. But I felt comfortable, and I'm happy that I got it. Thank you. And thank you guys for all that you do.
Oh, absolutely. So proud of you. So thank you for sharing that information. It helps people feel maybe just a little bit more comfortable that, well, if Alfred can do it, then I can do it too, and you can. after you study for it. So, okay. So I contend that ham radio is an adventure. An adventure? What are you talking about, Gary? So an adventure is an unusual and exciting, typically hazardous experience or activity. But Gary, I'm just doing radio. I'm not climbing walls or mountains. I'm not mountain climbing or hiking, or I'm not even taking a fast sailboat out at high speeds. How can what I'm doing be an adventure? I'm just sitting behind my radio talking to people. Well, the thing is that sitting behind the radio and talking to people is the last step. We have to get there. We have to put our station together. We have to put antennas up in the air. We have to maybe get some power arrangements made and some grounding and some other things. And in all of those areas, we can have some hazards. So an unusual and exciting, typically hazardous experience, ham radio is an adventure. And it's because of those hazards that we need to pay attention to safety. And so that's what this chapter tonight is all about. And so let's go ahead and begin with the section 9.1, which deals with electrical safety. And I want to thank KZ4M, Tom Walton, who got this presentation started, and I've kind of modified it over the years. He points out to us that we don't want to work on live equipment unless it's absolutely necessary. Don't put yourself at risk there. Avoid working alone on energized equipment. That's important. And the other thing is never assume equipment is off or de-energized. Check with a meter or tester first. Actually go look and see the power cord. Is it plugged in? We've all done silly things. Don't make that the last thing that you do in ham radio. He suggests if we can have a master on and off switch for our ham shack. That way if you're shocked, your rescuers should remove power first, and then they're not exposed to the shock hazard as well. That switch should be clearly labeled and in a location away from equipment, and your family should know how to turn off power to your ham shack. It's an unusual situation, but be prepared. Oh, that blue is kind of hard to read. I apologize for that, but it says working on feed lines or antennas. Be sure that a transmitter or amplifier can't be activated. Lock it out. You'll get this presentation on paper and it'll show up a little better. I have to work on that one. If you're working on energized equipment, sometimes we have to. Just use only one hand. Keep the other hand in a pocket or away from the equipment. You're trying to remove a path of energy traveling through your heart from hand to hand. Wear shoes with insulated soles. Remove unnecessary jewelry. You've heard all of this before, especially if you've worked in industry. So electrical shock, well, the most dangerous are those that travel through the heart, arm to arm or arm to foot. And the current flow disrupts the heart's normal beating rhythm. 60 hertz household current is the most dangerous, interestingly enough. It penetrates the body and is of a frequency that disrupts heart function. And Tom should know because he's an EMS technician. So some deadly consequences. Unfortunately, I spent 20 years working for the Voice of America, and we had at least 2 fatal incidents during my time with VOA. I'll just briefly recap one at VOA in Greenville, North Carolina. The shift, normally they had a 4-man shift, but that night they only had 3 people on. And one of the technicians, a senior technician, was going to go back and troubleshoot a 250 kilowatt shortwave transmitter that was down. They needed to get it back on the air. two-man rule. VOA always had a two-man rule. You always had to have two people there if somebody's going to work on equipment. That night, they only had three people on shift. There weren't two men, and he took it upon himself to go back and work on the equipment. And he knew that the equipment should be safe because it had bleeder resistors in the power supplies that should bleed down the voltage on capacitors inside the device. What he didn't know is that that was the defect in the transmitter. That was what was keeping it off, is that the bleeder circuit had malfunctioned. He opened up the cabinet. They have doors, little, you walk into the transmitter. You opened up the cabinet. There was an interlock that should have cut off all power to anything in the transmitter. Except remember, the interlock was not working, or the bleeders were not working. He got into the cabinet, and we don't know exactly what happened, but somehow he came in contact with live circuits, and he was killed. And they didn't find him, for about 15, 20 minutes, and they go, where'd he go? So that's number one. He was a senior technician. I'll point that out. Number two was when I was the station manager at VOA's station in Kavala, Greece. We were at shift change at 4 o'clock in the afternoon, and a transmitter was down, and senior technicians said, well, we can find out what the problem was, and one of them bypassed an interlock and went inside a live cabinet. They'd done it many times before. This time, he came in contact with a circuit, and his last words in Greek were, "It got me." He was a senior technician. What I want to point out is that no matter how long you are in this business or this hobby or whatnot, don't think that you're immune to safety problems. So we want you to keep enjoying this hobby for a long, long time. So that was my attempt to kind of, bring home that this is important. When you're wiring your station, you need to follow the guidance of the National Electrical Code. And also, again, this blue is not showing up like I thought it would. Hopefully it's showing up okay for you. But local building department codes are also operative and actually may supersede the NEC. So if you're going to be doing wiring, know the local codes. And when in doubt, have a licensed electrician perform or check the work. If you're going to be doing wiring in your house, follow the standard wire color conventions. We talked about this. Black is the hot lead, white is the neutral lead, green is the safety ground. And let me turn on my laser pointer here. So here we have the black, and it corresponds to the short prong here. The longer prong is the neutral side, that's the white wire, and green is the safety ground. If the equipment has a metal chassis, we always say to connect that to a ground if at all possible, or use 3-wire AC cords and plugs because they have that safety ground built in. What it does is it prevents hazardous voltages from appearing on the chassis. And if you're doing wiring, make sure that you use wire that is rated for the work that you want to do. The current rating for wire is called ampacity. It's the amount of amperage that the wires can safely handle. And the most common sizes of house wiring, number 12 American wire gauge for 20 amp circuits. Number 12 is larger than number 14 for 15 amp circuits. So number 12 for 20 amp circuits, number 14 American wire gauge for 15 amp circuits. And there are protective components, fuses and circuit breakers. They prevent equipment damage and fire by removing voltage when there's a current overload. Make sure that you use fuses rated for the voltage and with the recommended current rating. And you'll always place a fuse or a circuit breaker in the hot wire circuit, not in the neutral circuit. And also, if you're going to be wiring up for an amplifier, for example, 240 volt AC circuits have 2 hot wires. So you need 2 circuit breakers for a 240 volt circuit. That's why 240 volt breakers are doubled. So opening a neutral does not remove voltage from equipment, so you never want to have a fuse or a circuit breaker in the neutral side. Another thing with the ham radio equipment, amplifiers, I mentioned interlocks at the VOA, and you actually open up the door and walk in, and there's an interlock that takes things down. Well, ham radio linear amplifiers also have interlock switches, kind of like this, that when you take the cabinet apart, if you remove the top part of the cabinet, it's designed to remove power and remove high voltage. Safety interlocks prevent high voltages from being present when a cabinet or enclosure is opened. They say never bypass an interlock unless specifically instructed to do so. Well, sometimes you're going to have to in order to troubleshoot, but use very special precautions. Make sure that there's somebody there with you while you're doing measurements so that you can find out what the problem is. But bypassing interlocks, you need to take special care. Ground fault circuit interrupters are required by code and good ideas, especially in areas where there's water, kitchens, bathrooms generally required. Ground fault circuit interrupters will trip if an imbalance is sensed in the currents carried by the hot and the neutral conductors. So remember I said the short one is the hot, and let's say 1 amp of current is flowing out of the hot. But if the GFCI senses that only half an amp is coming back, that imbalance will trip the breaker in just a few milliseconds. The idea is that that other half an amp has got to be going someplace, and it could be going through you. So that's what GFCIs are for. They're for life protection. It's where moisture or direct earth contact is possible, that they're generally required by code. Moving on to generators. A generator should always be in a well-ventilated area. If you're going to run a gasoline or a diesel generator, install it outdoors away from living areas. And just remember that exhaust fumes can be drawn into air intakes or windows and build up in poorly ventilated areas. The problem is carbon monoxide poisoning. You don't want to poison yourself or others, and if you can, install carbon monoxide detector alarms in your living and working areas. We use generators at field day a lot, and this is the rule: turn the generator off while refueling. I can't tell you how many times I've seen people refuel generators running. That's never a good idea. And refueling should be done by a team of 2, one person equipped with a fire extinguisher, and store fuel well away from the generator. If you're going to use a generator to power your house, keep in mind the safety of linemen in your area. If you're going to use a portable generator to power your house, make sure that you disconnect, visibly see that you've disconnected your house wiring from the grid. You can do that actually by removing the meter out of its socket. You can clip the seal on it and just pull it straight out. That will open up your house circuit from the line, because generators can backfeed all the way up the line, and if you've got a lineman working on a line outside your home, they could be electrocuted by your generator. So just be aware of backfeeding. Lightning is a safety consideration. Lightning protection provides fire prevention for your house, prevents electrical damage to equipment. If you can, disconnect cables outside your house if a thunderstorm is going to be occurring, and before the storm. unplug the cables. Now, a lot of times stations are put together such that you're not going to be able to do that. So what you need to consider then is grounding, grounding wires and straps. We've said this should be short and direct as possible. A lot of this is repeating from the technician class. All towers, masts, and antenna mounts should be grounded. Lightning grounds must be bonded to other safety grounds and earth connections. Use mechanical clamps, brazing, or welding for connections. Solder is not okay because solder joints may be destroyed instantly by the heat of lightning. So you want to use clamps or CAD weld or some other brazing or welding techniques to bond things together. And grounds that are bonded together, here we've got ground rods at various points and they're connected together with this halo. It holds all the grounds at the same voltage potential. And as I mentioned, when you're making these connections, they need to be mechanically bonded using clamps or CAD weld, which is a special high temperature fusion process, never soldered. What about lightning surges that might come up your coax? Well, we have lightning arresters for this. Polyphaser and others make lightning arresters. They're mounted on a metal plate, usually copper, and this is taken to a nearby ground rod directly, and the surge arresters will clamp the coaxial circuit over a certain voltage and keep surges from reaching the equipment inside the ham shack. All right, I'm going to play your mother right now. Wash your hands, especially if you use rosin core solder, because rosin core solder is a lead tin mixture, and lead is a poison. And you do not want to get lead poisoning, especially if you are doing some soldering and you're called in for lunch. Before you eat the lunch, wash your hands. Oh, we're here at questions. Let's see how we do. You can go ahead and unmute and answer these if you would. So why should solder joints not be used in lightning protection ground connections?
Alpha.
Alpha.
I heard alpha. A soldered joint will likely be destroyed by the heat of a lightning strike. That is correct. And which wire or wires in a 4-conductor 240 volt AC circuit should be attached to fuses or circuit breakers?
Alpha.
Alpha.
Yep, the hot wires. There are 2 hot wires, a neutral and a safety ground. So the hot wires need to have the circuit breakers. And according to the National Electrical Code, what is the minimum wire size that may be used safely for wiring with a 20 amp circuit?
Charlie. Charlie.
Number 12 wire for 20 amp circuits, correct? And which size of fuse or circuit breaker would be appropriate to use with a circuit that uses American wire gauge number 14?
Delta.
Yep, 15 amps, correct. And where should the station's lightning protection ground system be located?
Bravo.
Bravo.
Yeah, you want to keep the lightning outside the building, please. And which of the following conditions will cause a ground fault circuit interrupter to disconnect AC power?
Delta.
Alpha.
Bravo.
It is Bravo. Current flowing from one or more of the hot wires goes directly to ground, not returning through the neutral. And which of the following is covered by the National Electrical Code?
Charlie.
Charlie.
Yeah, electrical safety. And which of the following is true of an emergency generator installation?
A. Delta.
Yep. A. The generator should be operated in a well-ventilated area. Many generators can also be grounded, that's fine. And fuel should be stored near the generator? No. Fuel should be stored away from the generator, so it can't be all of those. Which of the following is a danger from lead tin solder? What did your mom say?
Wash your hands.
Alpha.
Alpha. Lead can contaminate food if hands are not washed carefully. And which of the following was required for lightning protection ground rods?
D.
Yes.
Delta.
They
Delta.
must be bonded together with all other grounds. And what is the purpose of a power supply interlock?
C.
Yes, to ensure that dangerous voltages are removed if the cabinet is opened, but don't assume that it's true. Make sure you double check. And where should lightning arresters be located?
Alpha.
Yeah, alpha, where the feed lines are entering the building. All right, very good. Section 9.2, radio frequency exposure. So here is the rule. What stations must comply with FCC rules regarding RF exposure? It's all stations with a time average transmission of more than 1 milliwatt. That's not a lot of power, so we're pretty much in it. We must comply with FCC rules for RF exposure. And this is relatively new over the past few years. RF exposure at low levels is not hazardous. The things that we need to consider are the power level or density, the frequency of a signal, the average exposure time, and the duty cycle of the transmission. And the two primary factors that determine how much RF a human body will absorb are power density and frequency. So I'd just like to remind folks of what I call the light bulb analogy. And I'm going to come back out to me full here, Bruce, just for a second. Whoops. And you can turn off the little me in the back. Thank you. So assume this is a 100-watt light bulb, all right? The old incandescent style, and if you move your hand, close to it, you're going to feel some heat, radiant energy coming from the 100-watt light bulb. And if you move your hand away, less heat. You move your hand closer, more heat. You put your hand on it, you're going to get burned. So the same thing is true with antennas in ham radio, is that the closer you get to it, the more energy is going to be absorbed. Definitely don't touch it, but moving away or adding distance also can reduce the energy from a ham radio antenna. So power density. Heating from exposure to radio frequency signals is caused by the body tissue absorbing RF energy. Power density is the intensity of the RF energy and measured on our scales in milliwatts per centimeter squared. And an example of power density is if you have a 10 milliwatt per centimeter squared signal, and the area is 75 square centimeters, and then the total is 10 times 75 or 750 milliwatts. We don't have to do any of those calculations, but I just want to show you that. Power density is highest near antennas. Dave, would you mute all, please? And highest near antennas in the directions in which antennas have the most gain. Increasing transmitter power increases power density, but increasing distance from an antenna lowers power density. Again, we don't have to do any math. These are just general concepts. Now, the specific absorption rate, or SAR, is the rate at which energy is absorbed from the power to which the body is exposed. And safe levels of SAR are called maximum permissible exposure, and it varies with frequency and power density and average amount of exposure. Body parts absorb RF best when the dimensions are similar to the wavelength of the energy. So this is in your book on page 9-10. It's the maximum permissible exposure. Here on the left, the vertical scale is milliwatts per square centimeter, what we talked about. And on the horizontal scale, it's frequency in megahertz. So here's 3 megahertz, here's 30 megahertz, here's 300 megahertz, here's 3,000 megahertz. And notice that we're allowed a higher maximum permissible exposure at lower frequencies, and then it starts to ramp down. And then in this frequency range between 30 and 300 is the least permissible exposure that we're allowed, and then it goes back up here. And there are also 2 lines, one for occupational or controlled areas, and the other for general population or uncontrolled. We'll explain these in a minute. Just note for ham radio, 6 meters and 2 meters. 50 megahertz and 144 megahertz are the bands that we have to be most concerned about. So for this evaluation, RF energy is averaged over fixed time intervals because the body responds differently to heating for short and long duration exposures. And time averaging evaluates the total RF exposure over a fixed time interval. So what we're looking at is exposure and time, and if we can reduce either of those, we can improve our situation. Controlled and uncontrolled environments, people in controlled environments are aware of their exposure. So here I say family members of hams. They know you're into ham radio. They know you have antennas. They can minimize their exposure, so a shorter exposure is assumed. Whereas your neighbors, people in uncontrolled environments, are not aware of their exposure, so longer exposures are assumed. And you can actually, by these signs, I've got a couple of them up here on my property, just to inform people of the fact that there's radio frequency fields here out in my antenna field. So back to 9-10 in the book, remember that the VHF range, 6 meters and 2 meters, is where we're the most sensitive to exposure. That has to do with the human body size. So there's 2 kinds of duty cycle. There's the transmit duty cycle. The transmit duty cycle is the ratio of the time that the transmitter is on to the total time of the exposure. So if your transmitter is in transmit only 50% of the time, that would be said to be a 50% duty cycle. If it's on 75% of the time, that's a 75% duty cycle. And if it's on only 25% of the time, that's a 25% duty cycle. With a 50% duty cycle, the maximum permissible exposure doubles. You can have higher exposure because you're transmitting only half of the time. So a lower transmission duty cycle permits greater short-term exposure. So that's the transmit duty cycle. There's also something called the emission duty cycle. What kind of signal are you going to be transmitting? Single sideband voice, for example, has a duty cycle between 20 and 40%. And you're transmitting only half of the time probably, so that further increases the amount of exposure that would be allowed. Radio teletype, CW, whatnot, those are 100% modes. So that doesn't help you there. FM, for example, is also a 100% duty cycle mode. But a mission duty cycle could come into play. And then what kind of antenna system are you using? Directional antenna systems use gain or have gain in a certain direction, and they increase the signal's average power. So if you have somebody who's being exposed here in this main beam, that's going to be a different story than somebody who's over here. So you have to consider these when you're doing an evaluation of your station. Remember, I told you the only ones that are not don't have to do the evaluation is when it's time averaged below 1 milliwatt. Now, you'll look in your book on page 9-12, and they give some guidelines that they say you're exempt from further detailed analysis. I just want to point out you're never exempt from the FCC's exposure limits. But what they're saying is that in general duty, if these describe your kind of station, then you might just make a note that, okay, I've looked at my station and I don't feel that it causes any issues because of this. So here are the 3 examples that they give us. If you're on the 20-meter band, 14.1 megahertz, and the minimum exposure or minimum distance is 10 meters away from an antenna, you are allowed to transmit up to 1,700 watts. Well, since our legal limit is 1,500 watts, then what this says is that as long as you can keep people 10 meters away from your antenna, get the antenna 10 meters above the ground, or put fencing up to keep people 10 meters away from the antenna, if these are your operating conditions, then you need go no further. You've conducted an evaluation. You've evaluated the situation. But this is one of those situations in the book that they show that it's a possible exemption. I don't know why they use 22 megahertz. I'm going to say 21 megahertz because that's in the 15-meter band. Again, if you're 10 meters away from the antenna, the evaluation that they've done, they say if you're running no more than 433 watts, then you're okay. Now here, though, if you're running 1,500 watts, then you have to go further. Finally, 6 meters, 50 megahertz. Here we're 5 meters away from the antenna. The maximum power you can use is 96 watts. So these aren't exemptions, but these are generalized evaluations that the ARRL has done that says you really need to go no further. And one more, 146 meters, 2 meters. You're only half a meter away from the antenna, and you're running no more than half a watt. You can see that 2 meters is going to be a problem because it's the most sensitive of all. So just be aware. Now, estimating exposure and station evaluation. All fixed amateur stations must evaluate their capability to cause RF exposure no matter whether they use high or low power. And a routine evaluation must be performed even if the transmitter peak envelope power and frequency are within the FCC rule limits. 1,500 watts is our maximum rule limit power. But yes, that could cause some issues. In the old books and in the old handbooks, there was this. It's the old interim standard. We had a 2-year period where we were transitioning from no evaluations being required to evaluations being required. This no longer applies. It used to be that if you were operating on 20 meters and you had no more than 225 watts of power, you were exempt. Just I want you to know that this doesn't apply anymore. So if you see this table, don't take it at face value. This was the interim standard. All right, Gary, you've talked a lot about radio frequency evaluation. How do you do it? There are 3 recognized ways that you can perform an evaluation. One is you can perform the evaluation by measuring directly the RF field strength with calibrated field strength meters and calibrated antennas. That's number 1. Number 2 is you can use computer modeling to determine the exposure levels. Oh, Gary, I don't want to have to learn how to do, well, it's not that hard. Or you can do math calculations based on FCC Office of Engineering Technology Bulletin 65. So the easiest one to use is probably the computer modeling, which we'll talk about for a second. But Bruce, if you'd follow me over to the green screen, I just wanted to point out that these devices do exist, and they're not all that expensive now. This is a calibrated field strength meter matched with a calibrated antenna. It reads from 10 megahertz up to about 3,000 megahertz. You can use it with our charts to calculate. I wish it was in milliwatts per square centimeter, but their scales are different. So I've got my little cheat sheet. You have to do some math conversion. But these are not all that expensive, maybe about $300-400 on Amazon. It might be something for your ham radio club to purchase and be able to loan out for people to make direct evaluations. It's something to consider. But most people are not going to be using these. Most folks will be using computer modeling. And by computer modeling, we can go to the American Radio Relay League's RF exposure website right here. Whoop, that was me. I mispushed. There we go. This is the website, and essentially you fill out a questionnaire. It asks you about your antennas, it asks you about your transmitters, it asks you about power levels, it asks you about your antennas, and at the end you will know, do I have to take further action? This constitutes your evaluation of your system. So this is the American Radio Relay League's. Then there's the Lake Washington Ham Club's online calculator, a very similar system. You can go to their URL and put in your station information and find out if you've got something that you need to address. The worst cases, the worst case frequencies, VHF, 6 meters and 2 meters. The worst case is legal limit power. And the worst case is antennas with higher gain. Just keep in mind that with those situations, you probably are definitely going to have to take a look and see. Now, you must reevaluate, once you've done an evaluation, you must reevaluate if you change to a higher power or change or increase your antenna gain or change antenna height. If you reduce your output power, you do not need to do a new evaluation. Only if you would add gain or power to the system. So what can you do if an evaluation shows that your transmissions exceed the limits? Reduce antenna gain, reduce average power level, take precautions to assure that an antenna cannot be pointed in a neighbor's direction, for example, or take action to prevent that human exposure exists to excessive RF fields. That's the bottom line, as we're trying to preserve life safety here. If you use a stealth or an indoor antenna, let's say an attic antenna, you especially need to make sure that the maximum permissible exposure limits are not exceeded in your home's living quarters. Because in this case, you're much closer to an antenna than stations with outside antennas. Mobile antennas, if at all possible, should be placed on the roof of your vehicle, not on the side. On the roof, it's harder for people to reach up and grab them. And always use a dummy load when you're testing transmitters. A lot in there. Let's see how we can do here on the test questions what we retained. So what is one way that RF energy can affect human body tissue?
Alpha.
It heats body tissue. And which of the following is used to determine RF exposure from a transmitted signal?
Delta.
We're concerned about its duty cycle, its frequency, and its power density, so all of those. And how can you determine that your station complies with FCC RF exposure regulations?
Delta.
Yeah, these are the three ways. By calculation based on the FCC Office of Engineering Technology Bulletin 65, by calculation based on computer modeling, or by measurement of field strength using calibrated equipment, all of those. And what does time averaging mean when evaluating RF radiation exposure?
D.
It is D.
Delta.
It's the total RF exposure averaged over a certain period. And what must you do if an evaluation of your station shows that the RF energy radiated exceeds permissible limits for possible human absorption?
A.
Alpha.
Yeah, you have to take action to prevent human exposure to excessive RF levels. And what must you do if your station fails to meet the FCC RF exposure exemption criteria?
A.
A.
Yep, you have to perform an RF exposure evaluation. As far as I can see, the exposure exemption criteria is the 1 milliwatt averaged over time. So we're all required to do this. So what is the effect of modulation duty cycle on RF exposure?
Alpha.
Yeah, a lower duty cycle permits greater power levels to be transmitted. So 1500 watts of single sideband power is different than 1500 watts of radio teletype power, because radio teletype is 100% modulation duty cycle. So, yeah. And which of the following steps must an amateur operator take to ensure compliance with RF safety regulations?
Charlie.
Charlie.
You must perform a routine RF exposure evaluation and prevent access to any identified high exposure areas. You can put up fences. And what type of instrument can be used to accurately measure an RF field strength?
Bravo.
Bravo.
What I just showed you, but notice it's a calibrated field strength meter with a calibrated antenna that matches. And what should be done if evaluation shows that a neighbor might experience more than the allowable limit of RF exposure from the main lobe of a directional antenna?
Charlie.
C.
Yep, take precautions to ensure that the antenna cannot be pointed in their direction. And what precautions should be taken if you install an indoor transmitting antenna?
C. Charlie.
Yeah, make sure that the maximum permissible exposure limits are not exceeded in occupied areas. And what stations are subject to the FCC rules on RF exposure?
D.
A.
Delta.
Yeah, all stations with a time average transmission of more than 1 milliwatt. Very good. Did good. All right. Outdoor safety. So the most important rule for installing antennas is place all antennas and feed lines well clear of power lines. And if you're installing antennas, we have the 10-foot rule that dictates no part of your antenna system should be closer than 10 feet from power lines if it falls. So that means if you've got a 50-foot tower, including the mast and everything, and it's got to be at least 60 feet away from power lines, because if it falls over 50 feet, you want to have a 10-foot band so that you're well away from the power lines. Now, this is an optional rule of thumb to go at least 150%, but a lot of us can't meet that because of lot size, etc. But at least 10 feet, the 10-foot rule. This is something we don't think about, but don't run antenna feed lines over power lines or service drops. Because if your feed line comes down, it's going to lay right on that power line. And if the insulation is frayed or whatnot, you may get a big shock. If you're shooting lines through or over trees to support a wire antenna, remember power lines could be hidden in or just beyond the trees. So before you do that, make sure that you do a thorough visual inspection before starting installation. And when installing antennas, people should not be able to come in contact with the antenna once it's installed. You don't want them to get an RF burn if you're transmitting and they put their hand on the antenna. You can place a fence around a ground-mounted antenna to keep people away. And of course, read and understand assembly directions before starting your installation of an antenna. If you're going to put up a tower or a mast, if the mast or tower requires guying, if at all possible, keep all lines and guys above head height. Or if the guy anchor has to be low, make sure that you flag or fence the guy so that people don't walk in to the guy wires. If you're going to put up a tower, building permits are required most of the time for crank up or tilt over towers. You must comply with your local building codes. And towers should be grounded with separate 8-foot ground rods for each tower leg, with the ground rods bonded to the tower and to each other. And if you're near an airport, you're going to have to comply with both FCC and FAA rules. So if you're going to do antenna and tower maintenance, make sure that you turn off the transmitter and disconnect the feed line. You don't want to have the feed line energized if somebody's going to be on the tower. Climbers and ground crew must wear proper safety equipment, a properly rated safety harness that is current, hard hat, gloves, sunblock, goggles, boots, work shoes, and have enough crew to do the job safely. Don't try to do something on your own. And if you're new to tower maintenance, well, volunteer. Volunteer to help someone else do the work. And hopefully the goal is for you to be trained in proper tower maintenance or climbing procedures. You want to get the training first before you start climbing up a tower. And you have to have nerves of steel sometimes to get up and work at height. Some people just love it, though, so more power to them. Safety checklist. Before starting, inspect all tower guying and support hardware. If you have a crank-up tower, make sure that it's fully nested, or if it can't be fully nested, then it's got to be mechanically blocked so that it can't guillotine down if the aviation cable inside should snap or something. Confirm that your climbing belt is rated for the weight of the climber and it's within the allowable service life. They can go bad over time. And inspect ropes and load-bearing hardware such as pulleys. And make sure that all circuits that supply the tower, if there's AC power, are locked out and tagged. And by that, comes from industry. You actually will, on circuit breakers, have a place where you can put a padlock. And the guy who's climbing the tower or doing the work has the key to the padlock so that they can't energize the circuit. And there's also a tag that goes on that says what's going on, what maintenance is occurring. So if somebody needs to energize that circuit, they can go find you, make sure you're safe, and then they can re-energize the circuit. Okay, more questions. So which of these choices should be observed when climbing a tower using a safety harness?
Bravo.
Bravo.
Confirm that the harness is rated for the weight of the climber and that it is within its allowable service life. They do have a shelf life. What should be done before climbing a tower that supports electrically powered devices?
Bravo.
Make sure that all circuits that supply power to the tower are locked out and tagged. And that, ladies and gentlemen, is the end of Chapter 9, and that is the end of the instruction part of the class. I'm so proud of you. You've done a great job. Classes are always free here, but we do accept donations. I'm asked about that sometimes. So here's the information. If you go to my website, w4eey.com, there is a PayPal donate link there if you'd like to send us some money to go further in producing classes and other instructional material. And I'm good on QRZ.com if you want to use the old-fashioned mail. And remember the ad at the start, if you're interested in either the technician class or the extra class in either the Zoom classroom or on YouTube, please send me an email, w4eey@arrl.net. Before we take our break, are there any questions from anyone? Okay, not hearing anything. Let's go ahead and take our 5-minute break, and then we'll take a practice test. In the meantime, go ahead and make sure you get a piece of paper and a pen or pencil and mark it out to 1 to 35. And we'll be back in 5 minutes.
Hey, Gary.
1 second. And we're back. Great to have you with us. So what we're going to do now is take a practice test. You get your general class license upgrade by passing a 35-question multiple choice test. And the questions and the answers that you'll be included are all known. They're in the book. And that's what we've gone over, all of them here in this class. So tonight we're gonna take our first practice test, and we'll have 2 more next week if you'd like to come back. I wanted to point out that in the question pool there are 429 questions for the general class question pool. And if there are no repeats and you took 35 question practice tests, you would need to take over a dozen practice tests to cover all of those questions. And you'll find that there are repeats. So, taking 15, 20 practice tests is not too many in order to review all of the questions. So what I'd like you to do tonight is to get out a blank sheet of paper, number 1 to 35, and we'll have you write down A, B, C, or D as your answer to these questions. Then we'll go back. If there's any questions that you didn't get, we can go back and review it. Remember, when you're taking the test, there is no time limit, so we won't have a time limit here necessarily. Then we'll go ahead and review. You'll grade your own paper, and we'll see how you're doing, and we'll see how we did. So keep calm, and let's begin, and know that you can do it. And what I'm going to do, unless you want me to, I won't read the question and answer, but when we get to the answer, the correction part, I will, for those who are visually impaired. So here is question 1. Oh, and if you wouldn't mind, when you get done reading the question and have answered it, raise your hand if you're on camera. If you're on camera, then I can see you do that, and then I'll know to move on to the next question. So here is question 1. All right, so 2 hand waves. 3. Okay, so there's question 1. Here's question 2. Okay, and here is question 3. Remember, we can always come back. Okay, and here is question 4. And here is question 5. And if you need me to stop, just unmute and let me know. And here is question 6. Okay, and here is question 7. Okay, and here is question 8. And here is question 9. And question 10. And question 11. And question 12. And question 13. And question 14. Don't forget to raise your hands. Thank you. And question 15. And question 16. And question 17. And question 18. And question 19. And question 20. And question 21. question 22. And question 23. And question 24. And question 25. And question 26. And question 27. And question 28. Dave, can you go back to, to the first page? Thank you. And question 29. And question 30. And question 31. And question 32. And question 33. And question 34. And the last question, question 35. Now, are there any questions that you'd like to go back and take another look at? Just unmute and tell me the question number. Anyone? That's a first.
Number 4, please.
Number 4, okay. I don't have an easy way to do this, so I have to go back through them all. But number 4. And another. Okay. Let's see how we did. How did we do? So question 1, in a Class A amplifier, what percentage of the time does the amplifying device conduct? C, 100%. 1C. 2, which of the following is a common way to adjust the feed point impedance of an elevated quarter wave ground plane vertical antenna to be approximately 50 ohms? D, slope the radials downward, 2D. 3, when is it permissible to communicate with amateur stations in countries outside the areas administered by the FCC? A, when the contact is with amateurs in any country except those whose administrations have notified the ITU that they object to such communications, 3A. And 4, at what point in the solar cycle does the 20-meter band usually support worldwide propagation during daylight hours? 4D, at any point. And 5, what is the minimum age that one must be to qualify as an accredited volunteer examiner? 18 years old, 5A. And 6, what is a beta or hairpin match? It's a shorted transmission line stub placed at the feed point of a Yagi antenna to provide impedance matching, 6D. And 7, what dB change represents a factor of 2 increase or decrease in power? That's approximately 3 dB, 7B. And 8, which element of a vacuum tube regulates the flow of electrons between cathode and plate? A control grid, 8B. And which of the following is true of an emergency generator installation? The generator should be operated in a well-ventilated area, 9A. And 10, what is a characteristic of HF scatter? Signals have a fluttering sound, 10D. 11, what is the common name of a dipole with a single central support? That's an inverted V, 11A. And which of the following is required when participating in a contest on HF frequencies? Identify your station according with normal FCC regulations, 12D. And 13, what is a possible cause of high voltages that produce RF burns? The ground wire has a high impedance on that frequency, 13B. It might be a quarter of a wavelength long. And 14, what is the purpose of a speech processor in a transceiver? It increases the apparent loudness of transmitted voice signals, 14B. And 15, what term specifies a filter's attenuation inside its passband? That's insertion loss, 15B. And I will note here, remember, don't memorize A, B, C, or D because it's going to be different on the tests that you get. They mix them up. So remember the answer. 16, what does time averaging mean when evaluating RF radiation exposure? The total RF exposure averaged over a certain period, 16A. 17, What is an advantage of using a ferrite core toroidal inductor? All of these. The magnetic properties of the core may be optimized for a specific range of frequencies. Most of the magnetic field is contained in the core, and large values of inductance may be obtained. 17C. And 18, which of the following amateur bands is restricted to communication only on specific channels? That's 60 meters. 18A. And 19, what is the function of a power supply bleeder resistor? It discharges the filter capacitors when power is removed. 19D. And 20, how do you join a contact between two stations using the PACTOR protocol? Joining an existing contact is not possible. PACTOR connections are limited to 2 stations, so 20D for our test. And 21, how does an inductor react to AC? As frequency of the applied AC increases, the reactance increases. 21A. And 22, what must be done to prevent standing waves on a feed line connected to an antenna? The antenna feed point impedance must be matched to the characteristic impedance of the feed line. 22B. And 23, which of the following would qualify a third party from participating in sending a which of the following would disqualify a third party from participating in sending a message via an amateur station? The third party's amateur license has been revoked and not reinstated. 23D. Which of the following is true concerning access to frequencies? Except during emergencies, no amateur station has priority access to any frequency. 24A. And 25, what is QPSK modulation? It's modulation in which digital data is transmitted using 0, 90, 180, and 270 degree phase shift to represent pairs of bits. 25D. And 26, what is the purpose of a corona ball on an HF mobile antenna? To reduce RF voltage discharge from the tip of the antenna while transmitting. 26C. And 27, which of the following statements is true of single sideband? Only one sideband is transmitted. The other sideband and carrier are suppressed. 27C. And 28, what item of test equipment contains horizontal and vertical channel amplifiers? That's an oscilloscope. 28A. And what should you do if a CW station sends QRS? Send slower. 29A. And 30, which is true of mesh network microwave nodes? If one node fails, a packet may still reach its target station via an alternate node. 30C. And 31, what is the limit for transmitter power on the 1.8 megahertz band? 1500 watts PEP output, full legal limit. 31B. And which of the following is typical of the lower HF frequencies during summer? High levels of atmospheric noise or static. 32D. And 33, what happens as a receiver's noise reduction control is increased? Received signals may become distorted. 33B, they're talking about the digital signal processor. And 34, which of the following components should be added to an inductor to increase the inductance? An inductor in series should be added. 34B. And finally, what is the total bandwidth of an FM phone transmission having 5 kilohertz deviation and 3 kilohertz modulating frequency? It's Carson's bandwidth rule. 5 plus 3 is 8 times 2 is 16 kilohertz, 35A. So the question is, did you have 26 correct? Did you have no more than 9 wrong answers? If so, you pass. But if not, please plan on coming back next week where we'll take 2 more practice tests together. And in the meantime, you can take practice tests at the ARRL link or with an app on your phone. And as a reminder, donations, there's a PayPal donate link at my website. My mailing address is good on QRZ. And if you're interested in the Amateur Extra class coming up in January, just please send me an email. I'd be happy to have you added to the class. Remember, classes are free. Any questions before we go tonight?
Yes, Gary.
Yes, please.
What was number 5 again?
That is going to require me to go back. Let me just check here. Number 5, the minimum age that you have to be a volunteer examiner, 18 years old, 5A. Super source. No, not yet.
Thank you.
You bet. Anything else? Just in case I have to talk.
Thanks, Gary.
73.
You bet. Alrighty. See you next week. 73, y'all.
Great, thank you.
73. Appreciate it, Gary.
Yeah, thank you.